Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is matrices and determinants. If you are in senior college, you are preparing for YF, for NECO, for GC, for NAPTEP, for JAMB, or any other external exams into high school, this topic, this lesson is for you. Okay. Lesson 2, equality, addition, and subtraction of matrices. We want to study when two or more matrices are equal, when they can be added and subtracted. So we look at these three concepts in this lesson. Before that, for updates, follow Petakus Educom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like and share this video to your friends, your classmates, your colleagues. Facebook at fb.me/PetakusEducom, Instagram at PetakusEC, Telegram t.me/PetakusEducom, WhatsApp via this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus Education Community, where you have access to quality, unlimited, and simplified mathematics teachings in series. So the first concept is equality of matrices. Two matrices A and B are equal if all three of the following conditions are satisfied. Number one, each matrix has the same number of rows. Very important. Number two, each matrix has the same number of columns. Number three, corresponding elements or entries within each of the matrices are equal or the same. For example, let's look at this example 1. So first, we check the first condition. The number of rows here, they are 2. This one, they are 2. That is satisfied. Number of columns, they are 3. Here is 3, satisfied. Then we check the corresponding element. The first element here is 3. This is 3. The next one is 4, followed by 4. Next one is 6, followed by 6. Then you check for the second row. You have 16. There is 16. Are you seeing that? You have 34. You have 68. The three conditions are all satisfied. That means the two matrices are equal. Now look at these two matrices. The dimension is 2 by 3. That is 2 rows, 3 columns. This is 3 by 3, 3 rows, 3 columns. Number of rows are not equal. That means the two matrices are not equal, and that is the symbol for it. Then also, if you check these two matrices, the dimension are equal, number of rows and columns, but when you check the element very well, there is 7 and there is 5. So these two corresponding elements are not equal. Therefore, these two matrices are not equal. So you must check for these three conditions before you can state that two or more matrices are equal. All right. Addition and subtraction of matrices. If A and B are two matrices of the same order or size, very important, then addition and subtraction of AB is defined to be the matrix obtained by adding or subtracting the corresponding elements of A and B. So for you to add or subtract matrix, the two matrices must have the same order. That is, the number of rows in the first matrix and the second matrix must be equal, and the number of columns must also be equal before addition and subtraction is defined. In other words, if you have matrix A in this form, the order here is mn, that is m rows and n columns. Look at another matrix B. The order here is pq, that means number of rows p, number of columns q. So if number of rows in the first matrix equal to p number of rows in the second matrix, then n number of columns in the first matrix equal to q number of columns in the second matrix, then you can add a b and also subtract a b. So for addition and subtraction, what you check is the dimensions or order or size. Once they are the same, I tell you, you can add and subtract such matrices. All right. So examples. Given the following matrices, you have matrix A equal to this, matrix B equal to this, matrix C equal to this, matrix D equal to this, matrix E equal to this. The first matrix is 2 by 2, matrix B is 2 by 2, matrix C is 2 by 3, matrix D is 3 by 3, matrix E is 3 by 3. 3 rows, 3 columns. Evaluate the following. Number 1, A plus B. You should add matrix A and matrix B. So A plus B means matrix A plus matrix B. If you check, the number of rows and columns are the same in matrices A and B. That means you can add. So when you are adding, you take the corresponding element. That is, the first element in matrix A is 2. Add to the first element in matrix B, that is 1. So you have 2 plus 1. Corresponding element in the same position. Yes. Then you have minus 1. You add it to 4. So you have minus 1 plus 4. See that? You take 3, then you add it to 2. That is 3 plus 2. You take 0 and you add it to minus 3. That is 0 plus minus 3. So this plus you have here now is because you are adding what you have here, then minus 3. So you add 3. 2 plus 1 is 3. Minus 1 plus 4 is 3. 3 plus 2 is 5. 0 plus minus 3 means 0 minus 3, and that is minus 3. So addition of A and B is possible because of the fact that matrices A and B have the same order or the same size or the same dimension. Are you following? Okay. Number 2, subtract A and B. That is A minus B. So you are doing the same thing in example 1, but you are subtracting. Okay, we carry out the subtraction. The order, they are the same now. Corresponding elements to element, you have 2 minus 1, that is 2 1. Then minus 1 minus 4, this is minus 1, subtraction sign followed by 4, that's minus 1 minus 4. For the second row, first column, you have 3 minus 2, then 0 minus 3. 2 minus 1 is 1, minus 1 minus 4 minus 5. 3 minus 2 is 1. 0 minus 3 means 0 plus 3, and that is 3. You see that? Okay. Example 3, B plus C. You should add B plus C. So this matrix B plus matrix C. If you look at the two matrices, the dimensions are not the same. Matrix B is 2 by 2. Matrix C is 2 by 3. Now look at it. If you are able to add these entries to these ones, what happened to 1 and 0? So because the dimensions are not the same, it means that B plus C is undefined. That is, B and C cannot be added because they have different or unequal size. You see that? Okay. 4, D plus E. This is matrix D. This is matrix E. 3 by 3 matrices. The sizes are equal. Therefore, addition is very, very possible, whereby you add corresponding elements to corresponding element. So you take 2 here, first element, you add to the first one here, that is 2 plus 3. You take 4, you add to 2, that is 4 plus 2. You take 3 and you add to 2, that is 3 plus 2. You do that row by row or column by column as you wish to do it. Now I can do first column. I will take 3 here, I will add it to 1, that is this form. Then I will jump to the last element in the first column, that is 0. We'll add it to minus 2 in this form. You can do it row wise or column wise. What matter is that corresponding element to corresponding element. So when you add 2 plus 3, you have 5. 4 plus 2, you have 6. 3 plus 2, you have 5. 3 plus 1, you have 4. I'm now in the second row now. 2 plus 3, you have 5. 1 plus 1, you have 2. Now third row, 0 plus minus 2, that is 0 minus 2, you have minus 2. 1 plus minus 1, what I'm saying now, 1 plus minus 1, that is 1 minus 1 equal to 0. Minus 2 plus 3, you are owing 2 and you have 3. When you pay, you still have 1, that is plus 1. Okay. 5, subtract E and D, that is E minus D. So you start with the first matrix the way it is in the question. You don't interchange it, especially when you are subtracting. Okay, so this is matrix E as you have it in the question. Then this matrix D. You must be careful because subtraction sign can be confusing. So if you take it corresponding element to corresponding element, so let's start with 3 first. 3, 2, that is 3 minus 2. You have 2 4, that is 2 minus 4. You have 2, 3, that is 2 minus 3. You see that? For the second row, the same thing. Third row, the same thing. Now let me explain what happens here. Okay, the 3 is what you have here now. This is the 3. The first minus is the operation of subtraction, which must come before minus 2, before the entry minus 2. Okay, so if you subtract, so next thing is to subtract. So if you subtract the first place, that is 3 minus 2, you have 1. You can see there. 2 minus 4, you have minus 2. 3 minus 3, 2 minus 3, you have minus 1. 1 minus 3, that is the second row now, you have minus 2. 3 minus 2, you have 1. 1 minus 1, you have 0. Minus 2 plus 0, you have minus 2. I'm now in the third row. Minus 1 minus 1, you have minus 2. 3 minus minus 2 simply means 3 plus 2, and that is 5. That is 5. Okay? Properties of matrix addition. The first property is closure property. The sum of two matrices of dimension m by n is another matrices of dimension m by n. That means if you add two matrices of the same dimension, the result is another matrix with the same dimension. Let's see that in this example now. You can see we added matrix D and E together. The dimension is 3 by 3, and our result is another matrix the same 3 by 3. That is the closure property of matrix addition. The second property is commutative property. What that means is that matrix A plus B is the same as B plus A. You can interchange the matrices. That is for additional. Then associative property. If you add A, B, C together first and add it to A, is the same as adding A, B together and you add it to C. Then you have additive property. That is, if you add a matrix to a non or zero matrix, the result is this. Remember, a non-zero matrix is a zero matrix whose all elements are 0. So if you add to any matrix, you have the matrix return. Another property there is additive inverse. Additive inverse is such that the matrix is negated. So if you add a matrix and its additive inverse, what you have is 0. So we have these properties of matrix addition. Let's apply one or two to solve one problem, and let's verify that properties are, of course, they are true. Okay, example 6. Given the matrices, this matrix A, matrix B, and matrix C, you are asked to show that A plus B is equal to B plus A. This is commutative property. You have to show that A plus B plus C is equal to A plus B first, then added to C. That is associative property. So the first one is commutative property, and you take it part by part. So let's take the first part. The first part is A plus B. So this matrix A, this matrix B. When you are adding, you must share the dimension. The dimensions are 3 by 3, 3 by 3 matrices. So if you add corresponding element, that is 2 plus 1 is 3. You see that? Okay. 0 plus 0 is 0. Then you have 0 plus 1 is 1. Wow. See that? Okay. So if you do that for the second row, you have 4, 3, 3. That is 3 plus 1 is 4. 1 plus 2, 3. 0 plus 3 is 3. For the third row in both matrices, 5 plus 1, 6. 2 plus 0, 2. 1 plus 1, 1. Sorry, 1 plus 1 is 2, is 2. Then you now take the reverse, B plus A, where you write matrix B first before matrix A. So the same thing, first entry 1 to 2, you have 3 there. Second entry 0 to 0, you have 0. Third entry 1 to 0, you have 1. If you do that for the second row and the third row, you have this result. Now when you compare this to this, what do you have there? The same result. That shows that two matrices obey commutative property. Okay, let's show for the second part associative property. So in the same vein, we take the first part first. So in this first part we obey the rule of Boltzmann, where you start from the terms inside the bracket, that is B plus C. So this matrix B, this matrix C, when you add together, following what we have discussed, okay, let me say that again. First entry to first entry, that is 2. Second entry to second entry, you also have 2. Third entry to third entry, you have 4. That is for the first row. For the second row and third row, you have the entire matrix. Now we'll now look for A plus B now. So this is matrix A and this matrix B plus C. See now, matrix B plus C now is what you have there. So when you add together, you have this result. We take the second part. In the second part, following the rule of Boltzmann, you start with the bracket, that is A plus B. So you have matrix A plus matrix B. If you add correctly, you have this result. So in A plus B plus C, matrix A plus B comes first. See that now? You add it to C. If you add correctly, you have the same result. When you compare both, you see that, okay, you are comparing with this now, yes, with this. So you see that matrix A plus B plus C added together is equal to A plus B first added to C. This shows that matrix addition follows associative property. Associative property. Okay, example 7. For the following matrices A and B, verify. This is transpose now, what we learned in lesson 1, that A plus B transpose is equal to A transpose plus B transpose. So in the first part, you add the two matrices and you take their transpose. In the second part, you take the transpose of the two matrices before adding together. So for the question, you know matrix A and matrix B, so let's get A transpose. You take the first row and you make it the first column. You take the second row and you make it second column, that is transpose. Then for B, if I'm taking it column wise now, I will take the first column and make it first row. I will take the second column and make it second row. we take the third column and make it third row. In the first one, I used row wise. In the second one, I used column wise. But you don't miss both. If you are taking it row wise, you maintain it all through. Okay, so let's add first A plus B. So this matrix A, this matrix B, they already have the same dimension, so addition is possible. So if you add corresponding element to corresponding element, that is 1 plus 2, 2 plus 3, 3 plus 4, and others, you have this result. Then A plus B transpose, you have to transpose this matrix where you take the first row 3, 5, 7 and make it the first column here 3, 5, 7. You take the second row 5, 13, 12 and you make it the second column 5, 13, 12. Okay, so we've got to the first part. The second part is A transpose plus B transpose. So this is A transpose, this is B transpose. They are also the same dimension. You have 3 rows and 2 columns, that is 2 by 2. 2 by 2. Okay, so we are adding now. You add 1 to 2, then you add 4 to 1. That is the first row. For the second row, you add 2 to second row. Okay, for the second row, you have 3 and 2, which you add in this form. Then 5 and 8 follows. Then third row, you have 3 and 4, then 6 and 6. So when you add, you have 3, 5, that's correct. 5, 13, that's correct. 7, 12, that's correct. So compare this with this. So what do you see? That is transpose of a sum. Transpose of a sum. If you add 2 matrices and transpose it, then you transpose the 2 matrices before adding them, you have the same result. So therefore, A plus B transpose is equal to A transpose plus B transpose. So you see that if you follow the rules of in fact, the only rule I see in addition is that the size or order or dimension must be the same, and you add corresponding element to corresponding element for addition. Same thing for subtraction. I tell you, you have the correct result. Okay, end of lesson 2. Thanks for watching and learning with Petakus education community. Don't forget, watch out for more from the voice of Petakus. The voice you are hearing is the voice of Petakus. For questions and inquiries, use the comment section. We attend to them. For the complete package of this lesson, of this topic, lesson 1 to 11 for offline usage, contact the voice of Petakus via this WhatsApp number or through the email address. At a very little token, you get the complete package delivered to you. Lastly, if you are not safe, your life will be in crisis or is already in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you big congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be led. Take care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely, and the Lord will bless you. Goodbye for now.